Okay, good morning, everyone. Thank you for joining us this morning on this morning's webinar for safe isolation and electrical safety. My name's Simon Hobbs. There's still a few people joining us, but I'll make a start because we've got a little bit of an introduction and things to go through. We've got a great attendance this morning, which is good to see. And just so that I know that everyone can hear me, you should have a button that allows you to raise your hand. Would you be able to push that for us? That's magic. I've got lots of people raising their hands. That's great. Thank you very much. Okay. So the fact that I know you're all here and you can all hear me, I'm being assisted this morning by my colleague, Greg Jarvis. Are you there, Greg?
Yes, I am.
Okay, lovely. That's great. So what we also have this morning, which we've had on our previous webinars, is an opportunity to ask question and answers or do a question and answer session. You will hopefully see a box that says Q&A. As we're at the beginning or as we go through, if you've got any questions that you'd like to ask, and we'll do our best to answer them. And we'll save those till the end and then sum up all the questions at the end and work our way through those. Okay, so without further ado, this morning's agenda, we're going to be about half an hour, as we have been with previous webinars, and we're going to have a look at a couple of three subjects within the topic we've got today. First thing we're going to look at is legislation and guidance documents. Second thing then, obviously, is what we're here for, which is going to be a detailed review of the process of safe isolation for electrical works. We won't be looking at other reasons for removing the electrical supply, such as switching off for mechanical maintenance, emergency switching, emergency stops, functional switching and that type of thing, but we can discuss those in the Q&A if we need to. And then we're going to have a look at a final topic of some general electrical safety associated with isolating the supply. So I'm going to have a quick run through this. It's very easy to get our terminology mixed up with the subject of switching off the supply. Because isolation and switching are two very different things and they're used for different purposes by different people. So to start with, I'm going to just whip through the relevant legislation and codes of practice, guidance notes and so on very quickly to have a look at what the law and what the codes of practice say about isolation. So the first thing to look at is the Health and Safety at Work Act, and that imposes a general duty on employers to their employees in respect of health, safety and welfare. And for isolation, although it's not detailed in any way, it would generally come under section 2.2. There's also, as we put on the screen here, things to do with the Machinery Directive, PUA, the Management of Health and Safety at Work regulations. But in detail here, the Electricity at Work regulations are general in their application, but they also refer to what's called danger and injury. And we're going to have a look at that shortly in more detail, as these are really the prescriptive secondary legislation that deals with isolation and switching. So within the law and within the Electricity at Work regulations, the term danger is used, and it is defined as the risk of injury in certain classes of potential of harm to persons. And so injury is stated to mean death or injury from electric shock, burns, and the other things on the screen for you at the moment. So when we're looking at the law and it says danger, we can think of it in terms of risk of injury. And this will be really important in a few slides' time when we dive into isolation. So we must remember that danger really means risk of injury. So we've got other guidance documents, that's the law. Other guidance documents is of course offered by BS 7671 and its other accompanying guidance notes, such as the main one here, guidance note 2, which is specifically on isolation and switching. There is a new draft for public comment on the Amendment 2 of the wiring regs BS 7671 out at the moment, but I'll touch on that a bit later in the presentation this morning as well. Of course, there's other additional guides that are not British standards, but are good best practice and codes of practice guides written by industry bodies here, such as Electrical Safety First, and then organisations and companies will have their own processes, work instructions and method statements on how to carry out safe isolation and associated functions. So let's have a little drill quickly into what the law says about isolation. So what does the electricity at work regulations say? So regulation 12 says it is a means for cutting off the supply and for isolation. And just to read through the first couple of paragraphs and sentences here. Subject to paragraph 3, which is when we have a piece of equipment that generates its own energy, where necessary to prevent danger, or let's say risk of injury, where necessary to prevent a risk of injury, suitable means, including where appropriate identifying circuits, shall be available. So to prevent a risk of injury, we must be able to cut off the supply of electrical energy to any electrical equipment and the isolation of any electrical equipment. And isolation is very clearly defined as disconnection and separation of electrical equipment from every electrical source of electrical energy, could be a battery, in such a way that this disconnection and separation is secure. So that's the clear legal definition of what isolation means. Now they go on in the Electricity at Work regulations, regulation 13, to take a next step, and that's precautions for work on equipment that has been made dead. So I've switched it off and I've isolated it. Regulation 13 then goes on to say adequate precautions shall be taken to prevent that electrical equipment that has been made dead in order to prevent danger while working on or near it from becoming electrically charged during that work if danger may thereby arise. So not only have we got to switch it off, we've got to make sure it doesn't come back on, but they do use the term in the law electrically charged. So it may be that it needs to be prevented from being charged from another source or another activity somewhere else. So they're the legal definitions with regards to isolating the supply, making sure it stays isolated. BS 76771, the wiring regulations, clearly has a definition for isolation as well. And its definition says a function intended to make dead for all reasons of safety, all or a discrete section of the electrical installation by separating the electrical installation from every source of electrical energy. So we've got terms like electrical energy and electrical charge and so on. But in essence, we're going to be separating the part of the installation we want to work on from any other electrical charge or electrical energy that could come into contact with it. So why is it important to isolate correctly? Well, here's a couple of pictures and scenarios. The first one is we can't always be sure what the circuit is feeding, what equipment it's feeding. There's a lot going on in this street light. It may be that I switch off the main switch and everything is isolated, but it may be that I've got a back feed from somewhere else, a catenary wire feeding in at the top of the column back down, who knows? So correctly isolating is incredibly important when working in an installation like this. Sometimes there may be mechanical damage that you don't see before you remove the cover. So if I haven't switched off and isolated this device before removing the cover, the copper conductor under that brown insulation would be live, and I may be able to put my finger on it and get an electric shock. So clearly some mechanical damage could have occurred. And another scenario that we've got here is that not everyone demonstrates their competence. And this is a cover of a trunking that's been removed. And behind the cover of that trunking are homemade, uninsulated, bare copper terminals that are live. So if I haven't isolated the installation correctly before I've taken that trunking cover off, I'm exposing myself to an unnecessary danger. So these are sort of the moral reasons why we need to, as well as the legal reasons for isolating. So what can I use to isolate my low voltage installation? Well, again, BS 7671, the wiring regulations, under table, under part 537.4, has a table of devices with all the British standard numbers that can be used. And generally a circuit breaker will be suitable for on-load switching and isolation, and a disconnector or isolating switch would be suitable for offload functions. I've put a picture there of an old BS3871 circuit breaker. You might know them as a Crabtree C50 or that type of thing. They're not listed in the approved devices within BS7671, as we can see here. So the question should be, should they be used for isolation? Well, that British standard was superseded by 60898, BSEN 60898. So it doesn't mean that they are defective and shouldn't be used. But if we were carrying out an inspection, it might be something that we flag up as an observation or a defect. And certainly they're potentially devices that are reaching the end of their life. That table continues. And again, as we can see here, sort of halfway down, plugs and sockets can be used for isolation. So we can see halfway down, plugs and switch socket outlets, and the third column along isolation generally got a yes there. So plugs and sockets can be used for isolation. Maybe in some highway situations, that's a viable option rather than isolators and the like, isolating devices. Okay, so the main reason that we're here this morning is to look through the safe isolation. So we've looked at the legal and the moral reasons to carry out the work dead. And now let's have a look at the generally accepted process for safe isolation. And the first step will always be to obtain permission. If I go into this oil refinery and head to the main switch room, open the door and go up to the large isolating switch and turn it off, there will be a lot of unhappy people. Typically on highway electrical works, we generally have permission by the fact that we're there, but if you're working on traffic signals and the like, again, wouldn't potentially be very happy if we just turned up and turned the traffic signals off. So that's something that we need to think about, obtaining permission. Step 2 is that we need to actually now identify what it is we want to isolate. Do I want to isolate the whole installation? Have I got an individual circuit or a couple of circuits that I need to isolate? And so I need to identify my point of isolation and then use that to isolate the circuit. And again here, typical equipment that we may find on site. Step 3 is, having identified the circuit that I want to isolate, I need to select the appropriate test equipment. So we should not be using any non-contact devices to prove isolation. Volt stick in this instance here. These are excellent tools for general work around electricity. Always got one in the pocket, but they should never ever be relied upon to prove that a system is dead and to work on. So super tool, never ever used for proving isolation. We must select the appropriate test equipment. A voltage indicator, a test lamp, a neon contact device, similar to something that's shown in the picture here. And of course, they should comply with GS38, which is the Health and Safety Executive's guidance on test equipment and the associated British standards that go with that. So having selected the appropriate test equipment, we now need to make sure that it works. Typically, we may use proving units, such as shown here, but ultimately we need to prove it on any known live source. So as long as I've got a low voltage source that I know is live, I can use that. Okay, so I've asked permission, I've identified what I'm going to isolate, I've selected my equipment and made sure that it's working. I'm now going to switch the circuit off. So I use an appropriate means of isolation device that complies with regulation 12 of the Electricity at Work regs. And I switch it off, and then in accordance with regulation 13, I lock it off and secure that device so it can't come back on. The next step would be to post warning notices. These very much go with locking off the device, arguably could all be one step together. But just for this morning, to keep it nice and separate, we've put that there, that the warning notices need to be posted as well. May be able to see on the label there, typical things that would go on the warning notice would be the operative's name, maybe the company they're working from, a contact number, the date, which is incredibly important, and if need be, the isolating, the equipment that's being isolated as well. Having now isolated and secured my isolation, I can now carry out my proving of the installation. So I will take my test lamp and ideally, certainly with a single phase installation, connecting to either earth or neutral first, so that I don't have a wandering live lead potentially. I'll then test between all conductors. So as on the slide here, typically we would be going something like line to neutral, line to earth, neutral to earth. And then if I've got a 3-phase installation, I would then be going between all of the line conductors, line 1 to line 2, line 1 to line 3, and so on. The next step is to make sure that my instrument is still working. And this is the final step before we're able to start work. And again, in case it's got damaged in any way during the works that I've been carrying out. Okay, so that's the steps. Low voltage, safe isolation. These are the steps to carry it out. Let's have a look at this in action.
Okay, Simon, we're here today to perform safe isolation process on a 3-phase distribution board, please.
Thanks, Carl. Have I got permission to switch the installation off?
You're good to continue.
Okay. So I'm going to take it off load and then isolate the main installation. As a skilled person, I am under control of the installation.
So you're okay to remove the cover of the distribution board in order to move to the next step?
I know where the live parts are and I'll be expecting them to be shrouded to IP2X. If not, I'll deal with that as I come across it at that time.
Thank you.
Okay, so next thing I'll use an approved voltage indicator or test lamp and I'll prove that it's working on a known live source or proving unit.
That's good.
And I am then going to carry out the test. I'll talk you through what I'm doing. So I'm going to go on earth to line 1,
Yep.
earth to line 2, earth to line 3. I'm going to go neutral to line 1, neutral to line 2, neutral to line 3. I'm going to go earth to neutral, and then I'm going to go line 1 to line 2, line 1 to line 3, line 2 to line 3. Prove that my unit's still working.
Why have you reproved that the unit's
So
working?
to check that it's still working and that I'm not getting any false positives or false negatives.
Thank you.
And before I carry on with any work, I'm now going to lock off and secure my isolation point with a lock off kit and a warning notice. Like so. And I'm going to take the key and secure that in my pocket, and now I shall carry on my dead work.
I'm happy that you've successfully completed the safe isolation process. Thank you, Simon. Okay.
Okay, so moving on to a couple of electrical safety issues that are associated or could be taken from safe isolation. What do we do when we've got 2 sources of supply? So this can be a bit of a headache, and you do need to demonstrate your competence as an operative in this situation. Typical secondary supplies may be standby generators, uninterruptible power supplies, micro generators, such as wind turbines and photovoltaic systems, solar panels and the like. The latter 2, so the wind farms and the solar panels, photovoltaic, are going to become more prevalent. They have become over the last few years, but they're going to become even more prevalent in the next few years to come, as a new Part 8 is proposed for BS 7671, the 18th edition, in Amendment 2. So there's a new Part 8, and Part 8 is to do with what's called prosumers. It's a general term that's being now used as prosumers, and it's to do with the fact that not only do we draw electricity from our DNOs, be it Northern Power Grid or UKPN or Western Power and so on. Not only do we take electricity from them, but we're now in a position where we can generate our own electricity and put it back into the grid. And we see that with wind turbines, private wind turbines and battery farms and solar panel farms and so on. So this has now been recognised within BS 7671 as a big new topic. Like I say, part 8 is proposed, and the draft for public comment is out at the moment. The comments are tomorrow is the closing date. So if you've got any thoughts or comments that you want to make on the 18th edition, the link is there, standarddevelopment.bsigroup.com. Jump on and you can bring up any of the proposed amendments and make some comments on them. But whilst an electrical permit to work, so let's have a look at electrical permit to work with regards to 2 supplies. Whilst an electrical permit to work must be used for an HV, high voltage system, because it has to be made dead before it's worked on, obviously, they can be useful in certain low voltage situations, such as when we've got more than one source of supply. It is only an administrative document, so it isn't going to stop electricity flowing, but these permits are primarily a statement that a circuit or an item of equipment has been isolated and made safe to work on. So particularly useful where we've got two sources of supply, both have been isolated, and then we would go through the process of issuing and receiving a permit to work. Really important thing with permits to work is that operatives must have been trained and competent in their use to either issue them and receive them, clear them and cancel them and so on. But whilst we're isolating typically day to day on a low voltage installation with one supply, not necessarily required. I think as soon as you start to move to maybe 2 sources of supply, that's when we would start to look at an electrical permit to work. What other problems might we come across? Well, what about unidentified cables? I found a cable, I've got a supply in a column, I don't know where it's fed from, I can't switch it off, I can't isolate it and so on. Where there is uncertainty regarding the isolation when removing unidentified cables or proving dead an unused cable, where there's not enough conductor exposed to enable the use of test probes, and remember isolation can only be proved by direct contact with a test lamp and the like, we have to assume that all conductors are live until they are positively proved dead. So what that means is that any work that's going to be carried out on an unidentified cable should employ live working techniques until all of the conductors are proved dead and isolated. So it's quite a big step to move to there with unidentified cables. Now, there are steps that we can move through. So if the cable cores are accessible, as in the picture on the right here, we could use a clamp meter, and we can use that to see if there's any current flowing in the cable. Any current flowing indicates that obviously the circuit is live and it's being used and it's drawing current on a load. A non-contact voltage indicator, shown on the left here, can be useful in these situations to make a preliminary test for voltage. But these can only be used where we haven't got a metallic sheath. So it can show where it's live. And if the volt stick tells you that the cable is live, you can assume that it is live. But if the volt stick tells you it's dead, you still have to assume that the cable is live. Once the insulation's been removed from the cable using live working techniques to reveal underlying conductors, a contact voltage indicator should be used as a means of proving dead in the usual way. Then with regards to isolating that cable, it may be that it needs to be pot-ended and a new feed supplied, or potentially it could be traced in a better way at that point. Okay, so that's touching briefly on unidentified cables. The final thing that I would like to just look at this morning is the use of single pole devices for isolation, typically a circuit breaker, for example. So what I want to talk about is where we use them in the situation where we may have what's called a borrowed neutral. We'll have a look at what a borrowed neutral is in a second. And a feature of a circuit, I'll call it a feature, is that it can be left by previous work, is that a borrowed neutral may be there. And here the neutral is shared between 2 circuits. Typically, a really, really common scenario that you might find this would be on a lighting circuit. So lights that are on a stairway in a house may share the neutral. The upstairs lights and the downstairs lights may share the neutral. I've personally found this scenario on highways, on private networks in the past as well, with borrowed neutrals. And they are quite dangerous. So let's have a look and see how borrowed neutrals come about and how the dangers occur with them. So we're here to look at the subject of borrowed neutrals. If I draw circuit 1 and it comes down to a lamp on the line conductor, and we've got a neutral that's returning like so, and this is traditionally and commonly at earth potential. What that means is that if I am standing on the ground and I touch the neutral conductor on that circuit, I won't get an electric shock as it's at earth potential. So what is the problem with borrowed or shared neutrals? Well, the problem occurs when I want to put a second light in, and I create circuit 2. So there's my line conductor for circuit 2. And for other reasons that we'll discuss separately, we use the neutral that's already there for circuit 1, usually to do with a length issue and having to not run in additional cables and cheapness. So again, if I'm here working and I can touch the neutral and I won't get an electric shock. Everything's functioning satisfactorily from an electrical point of view. The problem with borrowed neutrals occurs when maybe I'm going to start doing some work. So in this instance, and I haven't shown any switches, but in this instance, let's say on circuit 1, I'm going to isolate the line conductor, switch off the circuit breaker at the distribution board. So I've switched off my circuit breaker and I've now isolated circuit 1 to carry out my work on. But what we'll see here is that circuit 2 is still energized. And the problem occurs with a borrowed neutral when we start disconnecting components or maybe cutting through cables because we believe it's isolated. And if we look at it in this instance, if I'm now doing my work at this point, having disconnected equipment and what have you, assuming and suspecting that it's live, I've isolated, I've locked off, all the things we've talked about previously, current is still flowing through circuit 2, and unfortunately it's got nowhere to go on its return path, so it goes through me back to earth, and that's the danger of borrowed neutrals. Okay, so I preempted myself there because I do have one more thing that I'd like to talk about, which is something that doesn't often get thought, a bit of an afterthought, which is high protective conductor currents. And it's something that's becoming more and more of an issue as we introduce more and more electronic equipment into our installations. So as part of their normal operation, many electronic items such as computers, printers, games consoles and so on will cause current to flow in the protective conductor. As we see on the diagram there, the green and yellow is the protective conductor. This is often referred to as earth leakage current. And whilst the level of leakage current in a typical domestic premises is unlikely to be a problem, other types of installations, such as those comprised of a large number of electronic devices, the earth leakage currents can become quite a high magnitude and present quite a risk of electric shock if the circuit protective conductor becomes disconnected. So equipment having a protective conductor exceeding 10 milliamps should be connected to the supply by the methods laid out in BS 7671. And essentially that means that the bonding conductor, protective conductor, should be oversized or another bonding conductor run into the circuit. What we can see on the image in the current slide on the radial circuit on the left-hand side is that it's had an additional bond run back from the last socket to the main earthing terminal. And if this was not the case, then it's possible that anything metallic became energized at a dangerous potential. So again, if we don't carry out correct and complete safe isolation, it may be that there could still be dangerous currents in play. And the other thing is obviously that with these circulating currents, if we don't have large enough bonding conductors or we don't have additional bonding conductors, it might be that I'm working on the circuit and I'm disconnecting an earth bond from a column, for example, or what have you. I may have 10, 20, 30 milliamps flowing through that bonding conductor due to electronic devices on the network. It may be EV charging devices, it might be LED lanterns and so on. And the electronics within these devices can drive this earth fault current. So we need to be very, very mindful of disconnecting bonding conductors without carrying out correct isolation as well. Okay, so to sum up this morning, everyone, and thank you for joining us again. Maybe if all our installations looked like this, with the diagrams and requirements, safe isolation would be really straightforward. But as we know, many of our electricians, technicians, engineers, they have to tackle installations like this safely on a day-to-day basis. And it's a real tribute to the competence of the guys out on site and the girls that they work around these installations and do such a good, safe job. So that's the end of the webinar this morning. We've got a short question and answer session, which I'll bring Greg in on a minute. Just before I do that, I did just want to point out for those of you that are in attendance this morning that we have carried out a number of webinars previously. And if you did want to go back through our library of webinars and other information, there's a video playing right now. It's electricaltesting.co.uk, an info link on our website, and you'll see that we have a whole series of previous webinars there that are available to you to dive into and have a look at. So without further ado, that's it for me this morning. Like I say, thank you for joining us. Greg, if you'd like to rejoin me, I don't know whether we've got any questions from the floor.
Well, Simon, if you can hear me, yeah, I've got
Yep.
one question. I don't know whether you've got any questions on the page that you can see. Gary has asked, what's the difference between switching and isolation?
Okay, that's a good question. So it's just out of reach down here, my blue copy of my wiring regulations. So the difference between isolation and switching really is that isolation is a permanent function for making dead, for working on a circuit. As we talked about this morning, it would also involve ensuring that the circuit will not become live whilst we're working on it and so on. Switching, interestingly, isn't defined. The word switching, whilst isolation is, the word switching isn't defined in the wiring regs, but what is defined are other things like functional switching, and we also talk about mechanical maintenance and that type of thing. So in that instance, switching is a function for turning things on and off for operation generally, but it can be for some forms of maintenance, but really it's an operational function switching. A good example, I like a good example, the light switch. Okay, switching on and off a light switch is an operation of a function rather than an isolation. Hopefully that answers Gary's question.
Yeah. That's good. I don't know if you can see any questions on your page.
No, I think that was I think there's one more. There's which I'll let you ask to me, but other than that, no. I think either everyone's overwhelmed with the quality of the content this morning, or it's given them plenty of food for thought to go away with. So
I was going to say that the other thing is just to remind everybody about our next webinar on the 11th of February, which is going to be on BS-EN40 designs. It's going to be hosted by James Hill with a special guest. So we'll keep something behind the curtain.
Yeah.
But it's going to be very useful for those who are looking at perhaps summer baskets, and obviously covers things like Christmas decorations, perhaps LED lantern conversions, cameras on columns, all those sorts of things. So that's something that's been requested by one of our clients. So a webinar on the 11th of February, which is BS-EN40 designs. So
excellent, good.
There
is a question that has popped up. So for that, everyone's still engaged on the webinar, which is great. So I've got a question from Peter, which I'm going to answer, because it says, in the first video demonstrating safe isolation, should you have had gloves on in case there was a nipped cable when you opened the cover before you even had a chance of testing the installation? Peter, that's a great question. The video that we took for the purposes of the webinar this morning was very much in a domestic scenario and a domestic installation. And Typically, obviously, I isolated the installation before taking the cover off, presuming things are still live before we've done that. But the assumption is generally made in a domestic installation that the equipment has been installed correctly. And then the key thing is that the test instruments that I was using were two GS38. So in that instance, they've got finger guards, they've got undamaged leads, they're fused and so on and so forth. I think when it comes to highway electrical systems, it's pretty much industry standard that we would wear LV gloves. So if I'd replaced that with a video showing isolation in a street lighting column or a traffic signal pillar or something of that nature, absolutely, I would be wearing LV gloves. And it's a dynamic risk assessment on the nature of the installation that you're working on. But yeah, typically in a domestic installation, unless you do a visual inspection and it's in incredibly poor condition, typically you would rely on the equipment itself rather than any additional PPE for carrying out that function. So thanks for that, Peter. I don't know if there's anything else, Greg. I think that's pretty much it. Yeah.
Yeah, that's it, I'm afraid, on my end. Yeah.
No, that's great. All right. Well, it just leaves me to thank everyone for coming today. As Greg said, we've got another webinar on the 11th of February. Details of that will go out in the normal channels soon. Just for me to say, after a weird year, I hope everyone has a Merry Christmas and a Happy New Year, and we will see you all again in 2021. Thank you very much.